Okay, now we're going to do two questions that might be a little bit more challenging for some people, especially the last one, 4.2.6. But let's look at 4.2.5. The question is determine the equation g, the inverse of the function g to the minus 1, the inverse of function of g in the form y equals. Well, we're given this g of x, which is 1 half x plus 9 over 2. That's y equals 1 half x plus 9 over 2, another way of looking at it. Well, to find the inverse, this is the way they write it in the memo, in the government memo, the first thing you do is switch x and y. And then we're going to make y the subject by multiplying everything by 2. So this will turn into 9. That will turn into y. That'll turn into 2x. You'll have y plus 9 equals 2x. Subtract 9, and there we have it. In the form, the inverse in the form of y equals 2x minus 9. See, I multiplied everything by 2, and then I subtracted 9 from both sides. So there's the first question done, the inverse in the form of y equals. Well, now here's a question. It looks a little bit scary, but it's really not so hard. It says if there's another function that's the inverse function plus a constant, and it's a tangent line to f, determine the coordinates of the point of contact between h and f. Well, here it is. If this is the inverse function, if we add k, it's still going to have a gradient of 2. I want to go back here to the parabola. Actually, we can go look at the parabola right here. If I make a line here, I'm going to make a line in maybe red here, and I'm going to put it like this. And what they're talking about is they're thinking about a line that touches right here. That line with the gradient of 2 will only touch in one place here. Well, how can we figure that out? Well, grade 12s can figure it out because you've got calculus. You want to find out where along this parabola the gradient will equal 2, and that'll be your answer. So if you understand the question, it makes it a little bit easier, that's for sure. So what you want to do is take the function, put it in the form of ax squared plus bx plus c, take the derivative, because that's for finding gradients. You want to find out where the gradient of f of x will equal 2. Well, what you do is expand this. Go x plus 5 squared. There it is, x squared plus 10x plus 25. Multiply it out, and you'll get half of 25 minus 8. It's 4.5 here. Anyways, half of 10x is 5x. There it is. 1 half x squared plus 5x plus 4.5. Well, let's find the derivative. So 2 times a half is 1x. 1 times 5 is 5. So there's the derivative. We want to make that derivative equal a gradient of 2 because that's the line. Remember what I said over here? There's this line they're talking about. This line they're talking about right here. We want it to, if it's got a gradient of 2, it'll only touch in one place here. We want to figure out where that is. So all we do is we go x plus 5 equals 2, and we solve it. Hey, it must touch. The tangent must touch at an x value of minus 3. So that's your answer. Where does it determine the coordinates of the point of contact? It's minus 3 is the x coordinate. On the y coordinate, all we do is take that minus 3 and put it back into the function. Minus 3 plus 2 squared plus 5 is 2 squared, which is 4. Half of 4 is 2. 2 minus 8 is y equals minus 6. So there it is. So the big trick here is they're saying this is a function, but all it is a line. And where is it going to touch? And the key was right there when the gradient is 2. So we had to take the function, the parabola, find out when the gradient was equal to 2. So we found the derivative, which is really a formula, a function that's going to give you the gradient at any x value. So when the gradient is 2, we can get the x value that fits with it, and that's what we did. Okay, well, there it is. I hope it helps.